So our topic for today is all about the application of first order differential equation, specifically growth, decay, and investment. So the mathematical model for the growth, decay, and investment, so we have dp is equal to plus minus kp dt. So separating the variables, so we will have dividing both sides of the equation by p. So p will cancel out on this side. So we will have dp. So I'll just write it first. So we will have dp all over p is equivalent to plus minus k dt. Integrating both sides of the equation. So from the left side, we will have from integral of dp over p from po to p. And then on the other side, we will have integral of k dt plus minus k dt from 0 to t. So integrating both sides of the equation, we will have ln of p is equal to, so we have the limits PO and P is equal to plus minus K. And then the integral of dt is equal to T. Substituting our T and 0 values, so we will have only T. So on the left side of the equation, substituting our P and PO into our limit, so we will have ln of P all over PO is equal to plus minus kt. Taking the exponential of both sides, so we will have, I'll just change my ink. I'll have p over po, and then p over po is equal to exponential of plus minus kt. By cross multiplication, so we will have p is equal to po times exponential of plus minus kt. Here, Here, P is for the population at a given time. So P is a population at given time. So for our PO, this is our initial value of population. While our K, this is going to be our constant of constant of proportionality. Then plus symbolizes meaning this is growth, and then minus means decay, and then our t is equivalent to our time. So to see this, let's try example number 1. So we have here, compare the final amounts at the end of a year at 100% invested at 5% in two ways: simple interest and continuous compound interest. So first is, I'll just write our given. So we are given that PO is equivalent to $100 because that's our initial value. And then we will have our K, which is equivalent to 5%. So this is also equivalent to 5 over 100. Then we are required to solve for the simple interest and continuous compound. So by the way, so required we are required to solve for simple interest and continuous compound interest. And then we know that by the way, we know that the formula for simple interest, so simple interest is equivalent to p is equivalent to p is equal to po multiplied by 1 plus k all over 100. So and also the formula for continuous compound interest is So the formula for that is PO, P is equal to PO multiplied by exponential of KT, positive KT. So now let's try to solve this one. So for our uh, solution, I'll just change my ink. So, and then for simple interest, simple interest, so we will have P is equal to PO multiplied by 1 plus K over 100. Substituting our given, so we will have P is equal to our PO, which is equivalent to $100, multiplied by 1 plus our K, which is 5% over 100. So that's going to be our P for our investment. So P is equivalent to $105. $105. That's for simple interest. While for continuous compound interest, so we will have the formula P is equal to PO exponential of plus KT. And then substituting our given, so we will have P is equivalent to our PO, which is $100, multiplied by exponential of positive multiplied by our K, which is equivalent to 5 over 100, multiplied by T. Our T is equivalent to 1 year. So we will have P is equivalent to, using our calculator, we will come up with $105.1271. So that's the answer. Now let's go to our second example, which is this. For decay in radioactive substances. So our second example is a radioactive substance is known to have a half-life of 78 years. Calculate the number of years it would take for this substance to decrease to 10% its 10% of its original amount. So we are given that, I'll just write our given. So we are given that, mm, our half-life is equivalent to 78 years. And then uh, we are also required, we are required, we are required to get the number, we are required to get the number of years to get to 10% less. So we are required amount at 10% less. And then, so to answer this one, first is we should get always the constant of proportionality. So by doing this, so we also, uh, so let's try it to answer it. Let's try to get the constant of proportionality. So solution. So we know that the formula for this is P is equal to PO exponential of negative KT. And then we assume that we assume that we have 100 grams. So assume 100 grams of substance. 100 grams of substance. And then we know that the half-life of our given is 78 years. So we could meaning uh, the half-life is 78 years, and then after 78 years we will only have 50 grams of substance, right? Of substance. So this is going to be 50% grams of substance is going to be our P. While this one, our assumed value is going to be our P sub O. And this one is going to be our time. So substituting this one to our equation, into our equation, which is this. So we will have our P, which is equivalent to 50, is equal to our P sub O, which is equivalent to 100, multiplied by exponential of negative K multiplied by T. Our T is 78. And then, solving for K, so we will have dividing first both side of the equation by 100. So 100 will cancel out on this side. So we will have 50 over 100 is equal to exponential of negative K multiplied by 78. And then, getting the ln of both sides, so we will have ln, getting the ln of both sides. So we will have ln of 50 over 100 is equal to, using the rules of natural logarithm, so we will have negative k multiplied by 78. And then, dividing both sides of this by negative 78 to get our constant of proportionality. So, negative 78 will cancel out on the right side. So, we will have k is equivalent to 8.8865 times 10 raised to negative 3. So that's our constant of proportionality. And then we will use this one to solve for our required, which is about at 10% less. So solving this one, so we will have, meaning 10% less. So we will have our P is equal to 100 grams minus 10 grams, because we are given that we should solve for 10% less. So we will have P is equivalent to 90 grams. And then our P sub O, which is also still the same, which is 100, our assumed value, 100 grams. And then our constant of proportionality, which is equivalent to 8.8865 times 10 raised to negative 3. And then we are asked to find the time it takes to decrease to 10% of its original amount. So we will have, plugging our given, so we will have 90 grams is equal to P sub O, which is 100 grams, multiplied by exponential of negative K, our K, which is equivalent to 8.8865 times 10 raised to negative 3, multiplied by T. And then, as you can see, dividing both sides of the equation, solving for T. So we will have, dividing both sides of the equation by 100 grams. So 100 grams. So 100 grams will cancel out on this side. So we will have grams will cancel out. So we will have 90 over 100 is equal to exponential of negative 8.8865 times 10 raised to negative 3 times t, taking the ln of both sides. So we will have ln of 90 over 100 is equal to negative 8.8865 times 10 raised to negative 3 multiplied by t. Dividing both sides of the equation by negative 8.8865 times 10 raised to negative 3. So we will have negative 8.8865 times 10 raised to negative 3. So this one will cancel out. And then also on the left side, so we will have our t. So the value of our t will become 11.5 0.8562 years. That's the answer. Next is our example number 3. So we are given that a city has been found to have a population that triples every 4 years. If the city's population is 1 million in 2010, how many people were there in 1990? So we are given we are given that P is equivalent to 3P sub O because it says that it triples every 4 years. So it triples every 4 years. So meaning we have for initially we have 3 sub PO, and then we have P sub O, and then after 4 years it will become times 3. So we will have P is equals to 3 sub PO. And then our K, which is equivalent to 4 years. And then we are also given that one at uh we have 1 million population at 2010. So we are required to solve for P in 1990. So technically, we are looking for P here after 20 years. So our solution. So now let's try to solve this one. So we have the formula is P is equal to P sub O exponential of KT. And then substituting our values, so we will have our P, which is equivalent to 3 sub PO. So we will have 3 sub PO is equal to PO exponential of our K, which is equivalent to, so by the way, so we will have K multiplied by 4. Actually, this one is not K. This is not K. I made a mistake. This is not K. So substituting our given, so we will have uh PO will cancel out, and then we will have 3 is equal to exponential of K multiplied by 4. Then taking the ln of both sides, so we will have ln of 3 is equal to K multiplied by 4. Dividing both sides of the equation by 4. So 4 will cancel out. So we will have K is equivalent to 0.27465 per year. So that's going to be our K. And then now we have got the constant of proportionality. Now we will go to our required. So we will have 1 million is equal to P sub O exponential of K multiplied by T. So 2010 minus 1990, so that's equivalent to 20 years. So 20 years. And then, so this is going to be our T. And then our K, which is equivalent to this one, 0.27465, substituting this. So we will have 1 million is equal to P sub O multiplied by exponential of K, which is 0.27465 per year, multiplied by our time, which is 20 years. As you can see, years will cancel out. So we will have 1 million, sorry, 1 million, and then dividing both sides of the equation, uh, 1 million is equivalent to P sub O exponential of 0.27465 multiplied by 20, then dividing both sides of the equation by exponential of 0.27465 multiplied by 20. So this one will cancel out. And also on the left side, so exponential of 0.27465 times 20. So we will have an answer of 4115.479 people. We know that we don't have 0.479 of people, so we will round this one to 4,116 people is equal to our P sub O.